One of the most important aspects of a successful society is diversity, especially in fields integral to our everyday life like computer science. Although it is really important to keep accurate data on computer science degrees, current methods of data keeping are inaccurate and lead to a misunderstanding of the current situation. Join us as we talk to Bard College Professor of Computer Science Valerie Barr about how the current methods used to evaluate degree statistics are incomplete and how we can address these issues moving forward.
So my article in Communications of the ACM is about moving beyond the standard analysis of degree data. And we present 3 new ways of analyzing degree data, which we think will give people a better understanding of their student populations and who's being attracted into computer science and who's not coming in. The problem with only focusing on the standard data analysis is that we miss out on all of the nuance of which groups, which intersectional identities are being attracted into the field, which are not. And we don't get an accurate long-term analysis of what's been happening.
Professor Barr, along with her computer science professor colleagues Carla Broadley at Northeastern University and Manuel Perez-Quinones at the University of North Carolina at Charlotte, have been trying to solve this issue of flawed record data keeping for years. They are part of a greater effort called Broadening Participation in Computing, which aims to diversify the computing industry. In their article in Communications, the professors outlined 3 important recommendations to begin to solve the issues of BPC data tracking.
One thing we argue for is a cohort-based analysis. For example, we keep seeing that women's computer science degrees are 20% of the total number of computer science degrees. But that doesn't really tell us anything because women used to be 42% of the undergraduate pool, now they're 57% of the undergraduate pool. By using cohort-based analysis, we can see that we're attracting some groups in much greater numbers than other groups. And if we do this for intersectional identity, we can really drill down to see, are we getting Hispanic women? Are we getting Black women? Are we getting Black men? So we can do very nuanced analysis of who's coming into the field and who is not. We also suggest comparing the demographics of your computer science degrees to your overall university demographics, because obviously you cannot attract into a field students who are not at your institution, but you should be attracting in students in roughly the same proportion as their presence at the institution. And the third thing we look at is entropy-based models for being able to analyze the diversity within computer science at, for example, an entire state of colleges and universities. So you can get a reading of which institutions are doing well in terms of diversity within their computer science programs and which institutions have a long way to go.
Professor Barr hopes that in the future, more and more students will be exposed to the field of computer science and realize that even if they don't want to be a computer scientist, there is still a lot of value in the degree that can help them in real life and within other professions.
Our ultimate goal is to diversify computing and the tech sector because we know that diverse teams produce better products, but also we will produce technology that works better for a diverse population when we have diversity in the teams developing technology.
Learn more in Visualizing Progress in Broadening Participation in Computing, The Value of Context, a research article in the July 2024 Communications of the ACM,